No false start this time. So this is the Exploring Amazon Security Lake talk. So if you're expecting something else, that's what it is. Just a quick introduction about myself. So my name's Dakota Riley. I am the Vice President of Cloud Engineering at a company called Acquia Inc. Just a quick tidbit about Acquia. We're an AWS Advanced Tier partner. We focus pretty heavily on the public sector, doing things like cloud security, application security, security data lakes, the talk. And me specifically, I consider myself kind of a wearer of many hats across, cloud security, application security, a little bit of amateur data engineering, and trying to figure out ways to automate all of those. Fun fact about myself, I have 3 cats at home. I got married in April, and I'm local-ish, Northern Kentucky, so about an hour and a half drive from here. When I saw this, I was like, I have to come here, either as a speaker or a participant. So, pretty happy to be here with you guys. So just a quick, just overlay of how the talk will be structured. I'll kind of give the overview and, how we got here, right? What about security makes it worth pursuing a kind of data-driven approach with like a security data lake, right? And, what is a security data lake in the first place? Why would I use one? For those of you that are security professionals, you're like, well, isn't that a SIEM, right? And then we'll talk specifically about Amazon Security Lake and what it brings to the table for you. I'll highlight a couple different features of Security Lake that are kind of differentiators in my opinion, specifically the Open Cybersecurity Schema Framework. I'm going to start calling it OCSF and not try to pronounce that out every single time because it's in my slides multiple times. And the last 2 things we'll wrap up with the presentation will be just kind of like what you should do to get started beyond just turning it on, right? And a walkthrough of a Jupyter notebook where I have tons of different queries dissecting a sample Security Lake data set that I pulled down from my lab environment. So, I'm going to start the talk off with this, controversial, maybe not controversial statement that the security at its core is a data problem, right? Is anybody in here like, your full-time job is security related, like you're a cloud security engineer, professional, or security adjacent? I get that sort of, same. Really, the reality is like even in AWS by itself, there's tons of different security tools. There's log sources that are security relevant. There's business context information about your AWS environment, the state of your infrastructure. There's tools outside of AWS that if you're, anything bigger than a small company, you probably have application security tools, vulnerability management tools, all of those things, right? And all those things produce findings, and they're all different schemas, different volumes, different levels of importance, right? And that's really what kind of makes this kind of challenging. And, what the idea of a security data lake is trying to solve is not just having these scattered in different tools across the company, maybe owned by different teams. And to put a more practical example to it, I wanted to actually explore a hypothetical security incident, right? So, bear with me here. Let's say you're a cloud security engineer at your company, you're minding your own business, and you get this awesome guard duty alert for credential access, IAM user anomalous behavior, which basically sums up to this IAM principal started calling these APIs, like typically like get secrets or, reading the user data on EC2 looking for credentials, right? If you've dealt with these, that they can tend to be false positives, but in this case, we're going to say that it's not, and it's an actual security incident, but you don't know any of this, right? I'll give you the chain to start out, but the idea is that you say a developer accidentally downloaded a typo squatted Python package. That Python package looks for credentials on the machine, finds a set of static AWS keys sitting in your AWS CLI directory, and starts hitting those APIs. So the thought exercise I want to go through, right, is, what sources of data or context do you need to get from this guard duty alert all the way down to understanding that this is an actual live security incident, right? So anybody want to take a guess at one? So detective is like almost more like an analysis or a SIM tool, like it analyzes logs, but it is of that kind of similar vein. So I'll go ahead and maybe this first one's a gotcha, but the guard duty finding itself is a data point that has to get routed and contextualized. It could be through detective. I think detective actually integrates a security lake to your point as well. So it's definitely not a wrong answer. But that guard duty finding can't just be sitting in the console. It has to actually get to somebody that can do something useful with it, right? Say you go look at this guard duty finding, you're like, yeah, that's interesting, right? I want to know what that principal did. After that, and take a look at the actual API calls. That's where CloudTrail would come into play. You would typically probably query CloudTrail and look at the principal's history for maybe the last 24 hours or so. Maybe you look into it, you see some strange IPs or different weird user agents, or just the API calls look weird. So where do we go from there, right? And this one might also be a trick question, but the reality is in an AWS environment, enterprise environment with multiple assets, multiple AWS accounts, multiple employees, you really need to know who owns the AWS account, what is it used for, what runs in it? Like, is it a production environment? Is it just a lab environment that maybe is not that important? You need to know information about the developers that interact with the account, and even asset information, right? Because a common scenario could be like, you see some weird API addresses on those calls. Are they coming from our assets? Are they coming from IPs we've never seen before? So finally, all that, you go and look at this and like, hey, this is probably worth going and talking to my developer for. You go and talk to that developer, and he says, I have no idea what you're talking about. I didn't do any of this, which is an immediate red flag, right? Of that something weird is going on here. At which point, you would likely look at your OS endpoint logs, or if you have like an EDR tool. But case in point, and this is just a single use case, right? There's so many other data use cases in security, from like analytics, your vulnerability and like risk management. This is more of like a threat detection, IR incident response use case, but there's just tons of different things that could be solved with like a data-centric approach to security, right? And that's what a security data lake is trying to do. So if you don't know what a data lake in general is, it's just a place for using commodity storage to store structured and unstructured data. And we can apply, kind of multiple different tools on top of that. So one thing I want to give nod to is this idea of a SIEM, or a security information event management system. It's not, a security lake is not meant to replace a SIEM, right? A SIEM typically implies a very specialized set of capabilities, usually like alerting. But if you have all this massive data, you run into a lot of challenges with sending everything to that platform, right? One, that they're, from a performance standpoint, they may not be built to handle all that data. Two, a lot of them bill based on ingest, so it gets really expensive. And when you cross that with different use cases for the data, compliance and retention requirements. What if you have to keep a certain set of logs for, X amount of years, right? That, and it's a more flexible approach, right? That way you don't have to throw everything into a certain SIEM and say, you can only access it here. Putting it into like a security data lake type interface, say S3. You can use whatever analytics tool that you want to throw at it. You could have, I've seen a common pattern is you might have a data pipeline that streams basically data that it feeds your alerting mechanisms into something more real time, and the rest gets cataloged into a data lake for analytics. And finally, and obviously no technology tool is going to solve underlying organizational issues, but it is a mechanism to start to break down silos, right? Where you don't have, my team owns this data, you have to go talk to them, which is really common in security. And especially if you're trying to chase down that incident I mentioned, you're probably on a cloud security team and you might not have access to all those other data sets. So, really quick, I kind of already touched on these, but, it's not a replacement for a SIEM, right? It's usually meant to be more complementary to that type of capability. It's definitely not a magic fix. And, there's a lot of data engineering expertise that goes into building one of these outright. So that's where Amazon Security Lake enters the picture. So Amazon Security Lake is basically a managed service for starting to run your own security data lake in AWS, right? It's basically S3 backed, so you can interface with whatever tool that can interface with S3. There are out-of-the-box integrations for most of the major AWS security log sources. So, things like CloudTrail, Route 53 resolver logs, VPC flow logs, Security Hub, which Security Hub is encompassing of a lot of different tools. And one interesting thing about this too is Security Lake will actually access these logs out of band, so you don't have to, say EKS audit logs, you don't have to set up a CloudWatch log group subscription to plumb them into Security Lake. So that's another thing you don't have to manage. And then the biggest selling point, which I'm going to dive into, at least the OCSF aspect, is on top of all this getting plumbed into the Security Data Lake, you get managed OCSF transformation, and you get transformation to Parquet, which is a format that's optimized for querying. So, and I feel like I had to put the slide in here because I've had, different talks with different stakeholders, and sometimes I'll explain what a security data lake is, and they'll be like, well, don't we already have that in Security Hub? And there is some overlap, right? At the end of the day, Security Hub does aggregate findings from security tools into a central spot. I think the biggest way to explain it as a differentiator is the interface in which you interact with those findings, right? So I don't know if anybody else has written code to interact with Security Hub. I have, and your primary method of interacting with it is through the findings APIs, the get findings APIs, and they're opinionated or limited on how you can get findings out. And then on top of that, it's not, that those findings are not really like data APIs. They behave almost like control plane APIs where you're running into the risk of getting throttled, paginated, eventual consistency, right? So it's, and then you mix that in with, a multi-account environment, hopefully you're aggregating those up into a single spot. Maybe you're not. I've seen both. And then you're fighting with all that versus something like Amazon Security Lake or even just a general security data lake effort. You can use whatever analytics tool you want to throw at it. So, anything that supports SQL, right? SQL is such a flexible language that pretty much any question in your data you could dream up, you can express a SQL query to get that information. So this brings me to my next point that, I'm going to highlight in depth. And then, when we get to the Jupyter Notebook aspect, we're going to dive into this and look at a lot of the differentiators here. But what is the Open Cybersecurity Schema Framework? That's the last time I'm going to say it out loud. It's OCSF, right? And at its core, it's basically a community collective. There's a lot of, it is vendor agnostic. There's a lot of big security vendors, including AWS, that are sponsoring it and participating in it to model and normalize security data across all domains. Right. And my terrible screenshots there, what you're looking at on the left side is just basically the top level of a CloudTrail event that gets normalized into an OCSF schema event. Right. And there's a lot of advantages to this because, for one, if you're a consumer of this data, every time you interact with a new log source, you have to basically relearn and kind of mentally grasp its schema. Right. But with something like OCSF at play, once you understand like the kind of common core concepts of it, you can get the source IP address out of two different log sources with almost a very similar query. One other thing that's really interesting about OCSF is, outside of just the schema, normalized field names are awesome, especially if you're the one that has to interact with the data. They're actually kind of developing a classification for security events, right, of all types, right? So I tried to create a crazy graphic that showed everything, including classes and subclasses, and I found out that it looks really terrible. I'll show it in my queries. It comes out a little better, but what you're looking at here, these are the kind of the top level domain classes for events. So to give a practical example, stuff like CloudTrail actually gets classified in application activity as API activity, as do most of the other cloud provider logs. Some of the events get classified as authentication events under identity and access management. And, stuff like Security Hub falls under findings, right? So it's a really powerful kind of classification system where you can write queries and, I can go have a talk with somebody that maybe isn't as security savvy, but maybe is working with this framework, and I can say finding and they'll understand what I mean, right? Versus maybe I say Security Hub and they say, Google Cloud Security Command Center or something like that, whatever the GCP equivalent is, but we would both know that those tools generate findings and not system activity. So great, that sounds awesome. How should we get started, right? And when you go and turn this on in your account, really you kind of get exposed with this. This is the end product. Obviously you have the S3 buckets and all that, but you get a set of Athena tables that just expose your data. There's more to do off that, right? And the very first thing you should do before you even consider turning this on is look at your log volumes and costs, right? And Security Hub's not what I would consider an expensive, or not Security Hub, Security Lake is not what I consider an expensive service, but there is an additional cost on top of ingestion for like the normalization process of your logs. And depending on what type of log type you ingest, that can vary greatly. So your stuff like CloudTrail, Security Hub, those are generally super low volume, even in multi-account environments. But when you start looking at things like EKS audit logs, VPC flow logs, Route 53 resolver logs, you really want to sit down and say, Do we use these? Do we need all of it, right? Before you go and turn it on and get a surprise view or surprise bill, not a view. The next thing is you want to go and like out of those queries and tables, you want to start creating views that kind of model your use cases. And I don't want to spoil my examples in the Jupyter notebook, but a lot of the data sets basically stream changes. They don't give you an exact picture of what's going on right now, right? And that's usually a great first starting use case. The other thing that I've seen a lot of success with, even not specific to just Amazon Security Lake, but in general, if you're doing any type of security data lake effort, is getting helpful metadata tables. And the most common example I've seen in AWS is having a table that has all your account IDs, aliases, and classifications of the environments, because then you can tie that into your reports and you can say, give me the vulnerability posture of all my production AWS accounts and give me a friendly name because I can't memorize 50 12-digit account IDs. I haven't figured that one out yet. And finally, you want to get comfortable with OCSF. And this one was actually, I don't want to say a challenge, but it took me a little bit as somebody who was really comfortable with the CloudTrail schema to go through, I know all the top level keys of CloudTrail and can quickly write queries for it. But I had to invest time in that learning curve of OCSF to, get comfortable with the schema and really kind of get the full value out of it. But once I did, the amazing thing is that I can pick two different data sources that have a similar class and pick out the same fields. So with that, we will go over to the Jupyter notebook and take a tour of OCSF and different security data. So please wait. Okay. Let me see if I can zoom in a little bit. There we go. Obviously, I'm not going to expect you to read the entire query. And if anybody wants this, I have it in a repo and I can make it publicly available. But what I've got going on in this is a Jupyter notebook. I'm using DuckDB locally. It's just a replacement to Pandas. I've pulled down pretty much all the data in my US East bucket from Security Lake locally because it's not large, because this is just a lab environment I built for the purpose of the talk. And I've written a couple different queries to, look at different field types, look at how they compare to the standard data sets. And then I have a handful of use case specific queries around, threat detection, vulnerability management, and those are kind of at the bottom. So to start off, when I was talking about those subclasses and not creating a crazy graphic, what I wanted to show too is for each of these data sources that I have, what types of events are in them and how are they classified. So in CloudTrail, you can see that there is, API activity and authentication styled events, which makes sense, right? You're either interacting with the control plane or you're making an authentication call to exchange credentials. Security Hub and really any tool that produces an assessment of your environment is going to generate one of the findings variations, which, you have detection findings. I fired off a bunch of sample guard duty findings and I forgot to limit it by finding type. So there's 500 of them in there. Compliance findings, which consist of stuff like AWS config, access analyzer, other things get thrown in there. And then I also, for the purpose of the talk, I turned on Inspector and I threw in some juice shop vulnerabilities into ECR for scanning. So we've got some CVE data in there as well. Your Route 53 and VPC flow logs, nothing terribly surprising there. They're classified as network activity and DNS activity. And then EKS audit, kind of in the same vein. This one was curious to me too, because there are authentication events expressed in EKS audit logs. I'm surprised that that's not in there. I actually was running EKS for kind of an attack simulation a couple weeks ago. So I definitely did some authentication, but that's maybe just how the plugin maps it, but it's generally to API activity. And if you want to dive into a specific side, feel free to stop me. We've got plenty of time. But the next part is, let's look at one of those, right? A familiar one that's probably familiar to a lot of people in the room is CloudTrail, right? So how does direct CloudTrail querying compare directly to OCSF, right? So what I did here is I just picked, 4 super common top level fields: event name, event source, user agent, and then the username of an identity principal. And what you're looking at here is this is what the OCSF query ends up looking like. So you'll see that one thing to take away from the talk is that OCSF has these, I believe they're called containers, but they're really just structs or objects, top level fields of where it classifies, the certain field types. So in the case of application activity, there's a whole API container that contains operation, service. If it's not a cloud provider and an actual API, it would contain other metadata. There's an HTTP request section that encapsulates, the status code, the user agent, and a standard actor field that basically encapsulates the identity information, right? And I just basically did a distinct lookup here for the purposes of the talk, and you can see it's me doing things in AWS, right? So similar concept for VPC flow logs, right? And I think this one is really nice in this use case because VPC flow logs are not very friendly to parse and analyze, especially if you've looked at them directly. But there are actually containers for source endpoint and destination endpoint, which is awesome for analysis, right? So you don't have to remember, is it source IP? Is it source camel case IP? Common problems in security, right? So, and this is kind of a callback to my presentation on creating helpful views, right? And the example I didn't want to spoil is, one of the quickest ones out of the box is to create a view for Security Hub findings, because the default Security Hub table, it streams changes to every finding, right? So, if you were to select star from the out of the box table, you're going to get basically multiple records for a finding where it changes, where it goes from, new notified to suppressed, which is great for certain types of analytics. But if I just want to start with what is the current Security Hub posture in my environment, I can actually create a view that just gets the latest record date for that unique finding ID. How are we doing on time here? So this is just an example of kind of the helper table ideas, right? Like an AWS account metadata table. And, in a perfect world, you would wire this up to be automatically collected from Lambda, plumbed into S3. One for vulnerability management I've seen that's really common is the Cybersecurity and Infrastructure Security Agency known exploited vulnerabilities list, which is literally just a CSV you can pull down, and you could do a join on this and other kind of vulnerability management tools, Inspector. If you're using something that's not Inspector, that's not often not embedded. All right, enough about helper tables and queries and all that. We can look at actual use cases, right? So, for vulnerability and configuration management, there's a couple of really easy ones, right? We might look at, and I know this is something that, you don't want to take just raw metrics. You want to get the context behind those metrics, right? I'm definitely not advocating for, hey, you have 50 criticals. What's going on, right? There's context behind those, but, you can get counts on, hey, what is, per account, how many highs, criticals, and mediums do I have, right? Or what is the breakdown of those finding types across accounts, right? And the one that stands out here is you can see where I fired all those guard duty sample findings in that one account, because there's 288 detection findings. Let's see here. This is vulnerability findings. Let's go to a more interesting one here. So down here, this is where, and this is why something like OCSF and the idea of these domains and classes is super interesting, because if I say the word vulnerability, that means different things to different people, right? Some people will, and not that I think it's correct, but they might say vulnerability and they mean guard duty finding, right? Or even config, which I don't necessarily consider a vulnerability, I consider it a misconfiguration, but OCSF is attempting to apply a common vernacular to that. And what you're looking at here is an actual CVE posture, where I was just show me all the open CVEs in this environment and rank them by their EPSS score, which is, I won't spend too much time talking about. If you want to know about that, I can talk about it after the talk, and their severity level. Let's see here. And this is probably the last big thing I'll cover here, but this is an awesome feature of OCSF. It's called observables. And so those containers I was talking about in OCSF, there's all sorts of, not just ones for modeling the event, but there's ones that are kind of extensible, right? So there's one for enrichments that I don't cover here, and then observables. And what observables are basically any tangible thing that appears in the event at least once that you might want to query on. So two kind of raw examples I pulled, right, from Inspector. You're going to get the ARN of the container, right, the container repository. So instead of having to hunt this out of the event, I can make queries against the observables object, and I could say something like, let's see here. Okay, well, we'll jump around here for a second. Let's get down here. I could say, give me a count of all Security Hub findings that occurred against a particular resource ID, right? Again, you're seeing the kind of the side effect of kicking off the generate sample findings in guard duty. But, if this was a real kind of environment and I saw that there's 230 Security Hub instances that mention this one EC2 instance, that might be a good place to start looking at what's going on there, right? It's also really useful in CloudTrail too, where I can write a query that says, show me all events that mention this one resource or maybe this one principal, right? Without having to go and, go into the user identity object or the resources object or, even the request parameters. I believe it supports propagating it out of those into the observables as well. So that is the talk, right? Basically, my call to action is, look into Amazon Security Lake, right? If you're not taking a data-centric approach to your security, there's a lot of value you can get out of it, right? Versus, trying to fight with 50 different tools. So hope you enjoyed it. If there's any questions, happy to entertain or take or even comments. So. No questions? Comments?
Great job.
I would typically, so I'm pretty sure, I'll be honest, I did not deploy it into Control Tower, but I know in an organization you have to delegate a separate account to deploy it, right? So, I know there's the security account that gets created by Control Tower. That would be a candidate there. Like in my particular case, I just vended a new account and made it the Security Lake Administrator account, but definitely a separate account.